Before we get started today, I'd like to talk to you. Today we are graphing linear equations using XY charts, or what I like to say as the table method, using tables. So before you get started, I'd like you to write down this list of items that we are going to be talking about. Okay? Sorry about that. So you are taking notes on this list. Pause the recording, write down this list, and put it for your list of items to remember while graphing. All right, so now as we look at our coordinate plane, I drew a little sample. And really what I mean is, oops. Okay. So if this were, what I mean about no baby lines is I don't want to see a line like this, where it's very small and it isn't the size of the graph. Okay? Is everybody clear on no baby lines? Rather, I want to see it look like this. The size of the graph. Okay, I want to see it looking just like this. So if you can see, so number 2 says you have to use a straight edge. That includes a straight edge for the x-axis, the y-axis, and for the actual line. You need to label 2 points with the ordered pairs like I did here. 1 ordered pair, 2. Okay, at least 2 points. All work for the graph stays with the graph. So if there's a table that goes with it, it stays with it. If there is getting x alone or y alone, it stays with the graph. Everything that goes with that. So in other words, I don't want you to do all the graphs on one page and all the tables on another page. Does that make sense? It's like reading a book. I wouldn't go every 5 pages to read what's happening. I'm not going to be flipping pages in the middle of it. Number 6, all arrows on all lines, the XY axis, as well as the line that you are graphing. Number 7, no more than 1 line per graph unless solving for systems. That will be chapter 8. Are there any questions about the graphing rules? All right, so let's go on to the lesson. So today, you don't really need to take notes on this page. So I'm going to just, why is this not working all of a sudden? I'll just be explaining it. So in some equations, we have 1 variable. We solve it, we get 1 solution. Okay? If you had something that looked like x squared equals 16, the only way to make that true, there's 2 possible answers. All right, so when you have x squared equals 16, there's 2 potential answers. 1 clue to you is there's a squared. That means there's 2 solutions. 4 squared would equal 16, and negative 4 would equal 16 if you squared negative 4. I'm going to just stop there and not really teach you how to do that because that's for next semester. But what we're going to talk about today is when we have 2 different variables. When we have 2 different variables, I get to choose my x's. I choose what I want x to be. So if I want x to be 1 plus y equals 5, what's y going to be? 4. So when I choose 2, y is going to be 3. If I were to choose 4, if x equals 4, what would y be? 1. If x equals 3, what would y be? 2. Okay? And what these are basically, if I choose 7, y would have to be negative 2. And these are basically ordered pairs. I could choose a fraction. I don't have to choose these whole numbers. If I chose 1/2, right? 1/2 plus y equals 5, subtract 1/2, subtract 1/2, y is equal to 4 1/2. Or we could say 7/2, right? So these are our ordered pairs. And we could say, because there's so many possibilities of choices for me, I could choose 1/4. I could choose, 35/100ths. I could choose anything between 0 and 1. I could choose anything between 1 and 2. I could choose 1,000,000. I have infinite solutions. And then what we have are, if I have an x and a y, they're basically your ordered pair. So it'd be 1, 4, 2, 3, 4, 1, 5, 0. And we could make a table out of that. I just make the tables the x. The y is your y. Now, in our xy relationship, our ordered pair relationship, x, y, it's always that order. And x represents which kind of movement? Side to side, across. I like to call it the across movement. Side to side. And y represents your up and down movement. Okay, questions? Yes.
If we make a table, do we have to write the equation like x plus y equals 5 anywhere?
I'm going to show you. Yeah. So the first thing you'll be doing in tonight's homework is you will be determining whether the ordered pair is a solution. Now, we can tell if it's a solution if you substitute in the x is what?
8.
And the y is what?
3.
8 plus 3 equals -5. That would be 11. Does that equal -5?
No.
So, no, it's not a solution. Okay, next one. Go.
Next one.
What am I substituting?
Be 6.
How are you getting 6? I need substitution first. We're on number 2.
Yeah, right there.
Number 2.
It would be 12 equals 8 minus -4.
Good. And a negative is really because that's like a negative times a negative. So then we have 12 equals 12. Is that a solution?
Yes.
Yes, because they're even, it means they are a solution. When both sides are not even, equal. Sorry. So because when they're equal, it means they're both solutions. Yes, it's a solution. Okay, I'd like you to pause the recording and everybody, and you're going to work on number 3 and 4. Pause the recording. Hold on. Now let's check our work. On number 6, it is a solution because 6 equals 6. I do want you to finish it up the whole way. I do want you to do this. Right? Does that make sense? And number 4, -2 is not equal to 6. So it is not a solution. Are there any questions? Okay, so now state whether the given point is a solution to. So we can substitute in 3 times what? 2 minus 1 equals 5. 6 minus 1 equals 5. Is this a solution? Yes. Number 2, raising a quiet hand. Is it a solution? How about Gabriel? Okay, number 2, go.
It's not a solution because if you plug it in, it's 7 equals 5, which is not a solution.
It would be 7 equals 5. Okay, 3 times 4 minus 5.
Equals to 4.
12 minus 5. Oh, yeah, 7 equals 5. Does not equal, so no, it's not a solution. Okay, let's jump down to number 4. So if I'm doing 3 times 1/2, I usually make that 3 a fraction itself. It goes over 1. It will have the same value. Minus 3 1/2, I'm going to convert that to a mixed improper. So 3, 6, 7 over 2. So really, this is the same thing as 3 over 2 minus 7 over 2 makes what?
Negative 4 over 2.
Equals negative 4 over 2. And that equals negative 2. Questions? Yes.
So the problem is 3x minus y, and it's negative 3 over 3 and 1/2. So shouldn't it be positive when it isn't it adding because it equals to 5, not negative? Wait, where's the
Oh, you're right. It should be here. Sorry, I knew that didn't sound right. It should have been minus 7/2 because it's negative 3 1/2. So I lost a negative here. So that really makes it what over 2? 10 over 2. And that simplifies to 5. So is 5 equal to 5? That simplifies 5 equals to 5. So yes, it's a solution. All right, are there any questions here? Yes.
If we can, are we allowed to turn it into decimals?
Sure. That'd be fine. Okay, negative 1 comma 2. Negative 3 minus 2 is negative 5, does not equal 5. Okay, so is everybody's good? Yes. All right, so now we're learning to graph with tables. So we are going to do everything we talked about in that list. So the first thing we're going to write down 2x minus 3, and you are going to make your table. I want you to make your table a little bit different. You're going to make it like this. Okay, so if I want you to make your table looking like this. So you should be making it look like this. And you're going to put your y over here. And then I want to see the equation, 2x minus 3. So we can actually use this. The original equation had a 3, and then there was an x minus 3. And so I'm going to just write that all the way down.
No, it's 2.
Oh, it's 2. Look at me. 2, 2, 2. Okay.
Isn't it 1 plus 2 times 3?
It's 2 times x equals the y. I moved the equals y right over here.
Oh.
Right? So now, the first thing I'm going to do is substitute in. The first thing I'm substituting in. So 2 times negative 3 is what? Negative 6 minus 3 is? Negative 9. 2 times negative 3 is negative 6. Oh, times negative 2, sorry. So times negative 2. It's negative 4 minus 3 is negative 7. 2 times negative 1. It's negative 2 minus 3 is negative 5. 2 times 0. It's negative 3. 2 times 1 is 2 minus 3 is negative 1. 2 times 2 is 4 minus 3 is 1. 2 times 3 is 6 minus 3 is 3. Now what you get are these ordered pairs. Negative 3, comma, negative 9. Negative 2, comma, negative 7. You don't need this extra ordered pair. If you know that this and this is your ordered pair, you don't need to list it. Does that make sense? Does everybody understand how to get this table? And then I would plot them. And you will notice -1, comma, -5. You will notice that the first 3, if I go over 3 and down 9, I'll be like down here. That's off the grid. I can't plot these 2 points because they're not on the grid. But the next one, -1, down 1, 2, 3, 4, 5. And then I've got 0, 1, 2, 3. Is everybody understanding this? Do you understand how I want your tables? Even if you know a faster way to do it, I want you to start by doing that right now. And now, the worst thing you could do is graph everything and then not put a line through the points. You must take a straight edge and connect the dots. Now, how do I know what numbers to choose? How do we know what to put in the X and the Y? Anybody? Yes, Brady.
Numbers that came out of your chart.
But how did I know which ones to put there?
The ones that could fit into the graph.
Okay. Some of them fit, some of them didn't. Josh?
Is it because of like slope and where 2x? So
No? Yeah?
because the biggest number in the equation is 3.
No? You're not hearing my question. How do I know what to put in here, in the X column? How did I know how to get those? Yes.
By plugging stuff into the numbers.
Right, but how did I know which ones to use? Yes.
You start with the number there and then you add 1.
How? Before that, you're going to get this. You're going to get this. How do I know what to use?
In the equation, -3.
Yeah, but it doesn't say where to start. Yes.
You can use any numbers as
Any number. I get to choose. So put that in your notes. I choose. I choose the X's, meaning you, not me, Yamasaki. Okay. So, now let's look at the first 2 I wasn't able to do, right? Are you with me? So you're going to choose, what I want you to do is I want you to choose 3 points. You don't have to do all of these, all 6. You're going to choose 3. And you're going to go beyond those 3 with your straight edge. Okay? So you're going to choose, and the 3 you're going to choose, if this is a whole numbers, are going to be close to 0. You're going to choose +1, -1, and 0. You guys with me? Because look what happened when I chose -3. It was all the way down here. You guys with me? Josh?
Is this where we use riser or round?
You don't? Nope. Not today. It's table method. So you are choosing your X values. Okay, now, let me keep going. You're choosing your X values. You're going to keep it close to 0. 0, +1, -1. Do you have to do -3, -2? No. Do you have to do 2, 3? No. Do you choose a fraction? No. You don't want to get. We can choose a fraction, but if I choose 7/2, that becomes 14/2 minus 3 is 4. That means I'm going 1, 2, 3.5, and then I'm going up in the middle of a box. There is no way to physically know exactly if I'm in the right place. Graphing is exact. So don't choose a fraction. You want to eliminate fractions. I need to go. So, now the next thing that's going to happen is, that was easy because y was alone. So what would I do to get y alone? Go, Wyatt.
In this case, first you subtract 2x.
Good.
On the side,
And then I'm left with?
y equals -2x plus 5.
Good. Notice I put the x first. I want you to do that as well. And now I'm ready to graph it. On the next one, what am I doing, Brady?
Next one you would
And then,
Divide by 2.
good. And now, and when you're doing this, I would do it like this. Watch. Divide by 2, divide by 2, divide by 2. Y equals, what is the coefficient next to the x?
1.
There's a 1 here, so that's really 1/2. Bring the x to the middle, minus 2. I would jump right to that. Yeah, quick.
This is the y equals mx plus b.
Do not, yes, it is in that form, but you are not to use that form to graph. Just get y alone. Because it will work easier for your table. So, I'm teaching you 3 different methods. The first method is table method. It's a pain. You won't like it. The last method is the easiest. But you have to make your tables tonight. I'm going to jump right to... Okay, so this is what I mean. All your work for the graph needs to stay with it. I have to get y alone. So what do? Everybody. Subtracting 3x from both sides. Now, this is where things get tricky. Divide by 2, divide by 2, divide by 2. Y equals negative 3 over 2, drop the x to the middle, plus 2. Now, the numbers you choose have to be numbers that you can cross-cancel with the denominator. So you have to pick a multiple of the denominator that's close to 0. What would you choose? 2, 0, and negative 2. 3 points. Right? So now you're doing negative 3 over 2 times 2 plus 2. Those cancel. Negative 3 and 2 make what? No, negative 3, positive 2 make negative 1. Negative 3 over 2, I normally don't do it like that, but it's 0. So it's really going to make everything disappear except the 2. Negative 3 over 2 times negative 2 plus 2. These cancel out. It becomes positive. 3 plus 2 is what? 5. So do you see my ordered pair is negative 2, comma 5, and then you plot the point? Okay, is this clear to you? So, what I mean by the work, if I'm filling this out, I get y alone. Okay, my table, my y alone, and my graph all have to be next to each other. Yes?
So also when we're graphing, we also do the
3 points, but your line goes through them on and on. Don't make them baby lines. All right, that was it for today.